related for the cinema solutions. So again, Mr. John Andrews will be taking care for our today webinar. And Mr. Andrews, he had received a BA degree in architect high school for architect, and he's currently working as USG Middle East as our technical sales manager in the Middle East region. His professional interest for the last 25 years focuses on the development of gypsum solution of ceilings and partition with particular focus of acoustics, fire, and mechanical performance required in the measure of commercial projects. USG Middle East always plays a vital role in the MENA region to meet and present the latest technologies in building materials industry, and thus we are delighted for the continuous technical summits which are continuing on a monthly basis, where we have considered the last Tuesdays of each month, 3 p.m. KSA time, which is GMT +3. As always, we are saying that your attending and support were considered the main engine behind our success for these consecutive online webinars. This is to confirm the importance of the collaboration in the building materials industry between manufacturers, designers, distributors, and even contractors. At USG Middle East, we work very close with our partners, project stakeholders, and other businesses to share our best practices and find new ways to advance performance. Even we work more closer with regulators and construction influencers to meet the latest construction regulations and building codes for material supply complaints. For the attendees who are attending our webinars for the first time, as a quick brief about USG Middle East operation in a glance, USG Middle East has multiple manufacturing facilities based in Dammam, Saudi Arabia, Doha, Qatar, and Turkey that allow us to supply any project in speed and high technical support. And the company owns more than 1,300 registered patents, which is a result of our dedication of excellence and innovation. Please note that this technical seminar will be recorded and it will be shared with the participant after this meeting will end. Again, I need to thank our technical webinar speaker, Mr. John Andrews. Each participant will receive an 1-hour credit for continuing professional development CPD certificate after this webinar. Please send always your question to the chat box, and we will be answering all your questions immediately after the end of this technical event. Let me now leave you with my colleague, Mr. John Andrews. John?
Hello, everyone. We're going to be today continuing from last month, where we had an open forum discussion with Paul Schwartz. So what we intend to do today is to just move that a little bit further forward. So I will be initially just going over the basic acoustics and fire that are required within the cinema complexes, and then we'll move on to, as requested by a number of the people that participated last month, on the products and our actual solutions. So without further ado, I will carry on. Any questions, please ask at the end of the presentation. So, as Musbar said, we're committed to provide innovative new solutions for your cinemas, constantly trying to move forward with your own ideas and your own concepts. So we are open to look at totally new things and new designs, and the new ways that people are now approaching the cinema complexes across the region. So please reach out to us at any time, and we will actually be there to help you develop any new products or systems that are out there. So I will now move on to the basic acoustics, just as a reminder. One of the most important things in the construction of a cinema is the sound reduction from throughout all of different rooms within the complex itself. So we'll look at basically a weighted sound reduction, which we know as SDC or RW. These in the cinema walls, from cinema to cinema or cinema to circulation space, have got extremely high requirements, basically so that the enjoyment or the the viewing of the film is not interrupted by any external noises. We also, a vital thing that's within the cinemas is the NRC. This is the actual absorption, so it's the noise reverberation coefficient. So there's two ways. So there's a lot of people that say acoustics, and really we shouldn't be saying acoustics with anything, acoustic wall. What we should be saying is a weighted sound reduction wall, or what is the reverberation or the absorption properties of a wall. And to understand both of those is when we can actually move on and give you the complex and the designs that are actually required. If we look at a basic partition, and this is an abbreviation of a 2-hour presentation that we have, the sound is basically an energy, and it passes through the partition in the way it's shown. So we have the airborne transmission. So this energy will go through. So the number of boards or space that you provide there, we have to reduce this sound. Unfortunately, when we build walls, we have to have metal elements or studs within there. So the energy has a direct energy path, which is shown, as you can see here. So with the studs, we've got a potential that the energy flows across. So this is where we have high detailing and basically try and split the frames to reduce your sound. We have the direct to flow across, and then we have cavity dissipation, which is very, very similar to the reverberation. We're actually forcing the energy to bounce back on itself and not travel from one room to the other. So what that means basically is that if we look at the gypsum partition, if we double the mass of the boards, we actually get an increase in the weighted sound reduction. If we add an insulation within the wall, we get an increase. And if we lower the gauge of the metal within the partition itself, we get an increase. The double frame, sorry, I'll just move this slightly out of the way so that we can see there. And if we can actually split the frame, and we can actually get another increase. But when we look at these increases, or these incremental increases, are not huge. So we have to take into a lot of considerations to start achieving what's actually needed within the construction of a cinema wall. So if we look at a single partition, which we've got highlighted here, because of the airspace and the direct travel across, you're basically only truly able to achieve 32 to 45 dB. If we've put a double board in there, which I mentioned earlier, whereby we are doubling the mass, so this is the partition that we'll be looking for you, we gain then an extra 5 dB, so the maximum that wall will be achieving is roughly 51 dB. If we change the mass of the board itself, which we'll come to later, that also gives you a large increase in the acoustics. If we then, as you can see, if we then isolate the frame and only have a small connection across, we get a huge jump from 50 to potential 60 feet in the systems that we've got highlighted in these diagrams. So you will see that nearly all partitions that we put forward within cinemas are working on the twin frame solution. If, however, we could actually split these frames and have them not connected, then we have another great incremental jump of 7 dB. And this is something that we've worked on to make sure that we can actually achieve these numbers for you by patenting and designing a form of connection that goes across there that operates and performs in the same manner as not having a connection across. So if we look into the basic requirements that you have in your buildings, normal speech is something that you don't want to, you'd have as a reduction if you were looking at something like an office space or something like this, so that you're not interrupted. So you basically, it could be just a standard wall, maybe let's say from a storeroom to an external wall. We'd be looking at STCs or RWs of around 40. If you want to be able to have the strain to hear the speech pattern, which is what Paul was talking about last week, where we all talk generally 45, between 45 and 55 dB, we need that reduction to be at 55, so that it's very, very difficult to hear a conversation that's going across. Obviously, with cinemas, we have extremely well-developed and used speaker systems that are throwing out very, very high sounds and at all sorts of frequencies. So we actually now need to be looking at around 75 STC for the performance of the partition, so that you can't actually hear what is happening from auditoria to auditoria. So sound, when is sound actually better? If we increase the number of boards in a system, which you'll see later that when we start increasing, that will actually make the sound insulation better within a partition. Adding glass wool or even 2 layers of glass wool again will raise the acoustic performance. The cavity width, which you'll come on to, the bigger the airspace that you have between the boards, so that we get that reverberation within the airspace or the void between boards and dissipate that energy. The bigger the airspace is, the better your sound reduction will be. So you will find that when we are giving you solutions for your cinemas, it's very, very rare that you'll have a thin wall. Typically, most walls are from 350 upwards in width. The weight of the plasterboards is very, very important, because, as I was mentioning before, and we've covered on previous webinars, the density of the board reduces the energy or transfer of the sound. So you will find that by default, from looking at boards that we use for fire, which are very, very dense, we actually use those boards in our cinema systems, because that actually adds the mass to the cinema system and reduces the sound. And then obviously, again, with the thickness of boards, we get a much greater performance. The temptation for a lot of designers and people out there is to try and gain footprint on their wall by making their wall narrower. To do this, quite often, because of the heights that you have within the walls, you have to basically reduce your stud sensors. Now, this is sort of, it's really false economy of a sort, because if you reduce the stud sensors, as I was mentioning earlier, there's more paths for the energy to go across, because it's got a direct transfer through the stud. And in addition to that, if you go with a thinner wall, then there is less energy dissipation within the void. So just as a little bit of an interest for you, I've got these 2 slides the wrong way around, unfortunately. So when we are testing, and we covered this heavily last month, so all USG's all systems are tested to make sure that we meet the requirements that are set out by the operator, and meeting whichever speaker system, whether it be a Dolby or an IMAX sound that they're going to do. We actually test that, and I don't think Paul put this up before, we actually test that by basically having speakers that throw out a sound. This sound, we build the wall in between, and we actually measure the recorded sound on the other side to make sure that we achieve your weighted sound reduction. And just as a little bit of interest here, you can see part of the construction of the acoustic chamber. So this would be one acoustic chamber and this is the other. The interesting thing on this particular slide is if you look here, this is something that we basically isolate one chamber from the other to avoid flanking sound, and we'll look at flanking sound in a short while. This is why when we look at performances on site, more often than not, you would be looking for a performance on site, let's say from cinema to cinema, of 65 to 67 STC or RW. We would then have to be giving you a wall that performs in the laboratory, and this is very important when you're reading the specs, everybody. You then have to be given a wall that performs between 8 and 10 dB greater than the requirement on the actual site. Because this chamber has been built so well, we do not have any flanking sound. So this space that we have between the two here actually stops any energy going through the floor, going from one place to another. So when you receive specifications of manufacturers or from your subcontractors or your installers, you've got to ensure that the certification that they are providing you for the acoustic performance is 8, as I said before, 8 to 10 decibels over what you're requiring. So if typically you would find that the Auditoria to circulation space is around 60, you'd need to be providing a wall of about 67 to 68 to make the correct reduction in sound. And this is what we're talking about basically. The energy, the sound, will actually go through the junctions. So the junction with the internal wall is always the weak spot. So if you imagine sound is a little bit like water, if you don't make something watertight, it will leak. It's the same with the sound. So it's the air tightness. And so if you have any sort of space for the air, the sound will directly transfer through. And this is what we call basically flanking sound. And it's the detailing in flanking sound that is vital when we come to construction of the walls on site in all cinema complexes. So this can actually occur from slab to slab, so you can actually have it going through the floor. So this is something again to be careful of. We often recommend that the screed is poured after the partition has gone in, so as that the screed acts as a block, so that we don't have the direct transfer of the flanking sound in the thin screed. So you've got a solid piece of concrete rather than screed. And the ceiling junctions are always very, very weak because the ceilings are never up to the same acoustic standard as in the soffit. So that is always a very weak spot, and you'll see shortly how we put bespoke systems together for you to overcome those issues. The biggest problem that we have on the sites is basically plant noises coming through, which is usually especially with the refurbishment of cinemas, a lot of the plant is on the roof, so we have to make sure that that sound doesn't come down through into the auditoria. We have a tremendous amounts of services that we have to protect for the air conditioning and such like, that will also give you that airspace or that unwater tightness to the partition. So there's lots of extremely specific detailing that needs to be done to ensure that we keep the walls and everything airtight to stop any interference with the enjoyment of the actual show themselves. So when we're looking, when we're looking at this, I've just put this board up. Basically, we have lots of different types of board, and they perform in different ways, as this slide's showing into fire. But that is due to the density and some of the ingredients that we put in that board. Because of it was increasing the density, and typically we will be looking at this board, a fire board. That density of board is very, very good in acoustics by default. So you will actually see specific fire performances to partitions that are maybe not relevant, but those have been by default because we're actually looking for the board that is very, very dense to give us the acoustic performances that you need. And to give the board a lot of strength, both in fire and flexibility, we actually put a lot of blown fiberglass within the board itself. And it's the fiberglass and the vermiculite that we get in these boards that also change the density and the energy transmission across the board. So it's a combination of things, which is why, again, as I've highlighted before, we will use a fireboard or a very heavy density type X board when we are building a partition. The other major consideration for cinemas is these walls are very, very high. So we have to look at how much deflection is going to occur in these walls. And again, by default, which is coincidental, the wider the wall that you have, the actual better the structural strength of that wall will be. So we've got a wide wall required for fire, a wide wall required for sound, and also the same for the mechanical strength to stop it bending. Now, what we're looking at there is we're basically having a load. So within your cinema, you have an air load or an air pressure, and we have to match that air pressure in our laboratories or in our testing to make sure that those changes in air pressure or the air pressure that naturally occurs in a building stops the wall from deflecting above the chosen criteria that we've designed to. So this is generally, as a structural element, we generally base the deflection criteria on L/240. Now that is for stability. That is the, how I might say, the failure rate. So you actually use this figure L/240 to calculate the thickness and strength of your partition to make sure that it performs. But with the USG barrel, we actually go one stage further. We actually work to BS5234 on all our partitions. So what we're actually doing is restricting it or giving you a wall that's even stronger than the criteria set out in L/240. So we basically say that the maximum deflection on the wall is 10 millimeters and the minimum residual deflection. So once that wall has, the air pressure has bent the wall slightly, it will actually come back to being straight again with a maximum residual deflection of 1 millimeter. So on here you can actually see these are the tests that we do here, and we're actually adding double the air pressure that you would normally be doing to see what would happen to a very, very large wall and how much it will bend, and then we release that pressure to see how much that wall will actually come back to being straight. So the maximum height of your walls now actually depend on the dimension of the studs, the gauge of the studs, spacing, and thickness and type of plasterboard that I mentioned earlier, the numbers of layers of plasterboard, and the loadings or air pressures that are within there. So it becomes quite a complex calculation to make sure that we're achieving both the acoustic requirements that you need and the fire requirements and the mechanical strength that are required for these walls that sometimes are going up as high as 21 or 22 meters. Okay, so we just as a quick history there, USG Baffle, we actually did the first cinema in the KSA, and this was done in 70 days as a working project. So it was the very, very first one that came up. We also produced a wall, a cinema called Orbi, which was basically nature zones. This was quite a complex, challenging cinema to look at because we had actually extreme different temperatures within this building and very, very, very unusual shapes. And as you can see here, we had a huge, basically 180 curved screen that went all the way around there. So this was a 35-meter wide screen with 3D sound that we had to stop from the circulation spaces. So we had to basically build a fully curved high acoustic wall, which was a challenge to bend these 15.9 type X boards. So within that, and you can see some of the curves here. The cinema solutions that we have at USG Bar, we've got over 300 UL assemblies for the different partitions and to back up our designs for you. So they're all tested to UL standards. Within this area and in the GCC, as Musbar mentioned earlier, we're basically a single source now for all the elements that you will find in the building of the cinema on the inside. So you'll be, I'm coming to this now, which is the bit that you requested, which was the, we can provide the ceilings, the partitions, the feature ceilings, and everything along this sort of line for you. So now we go into the actual partitions yourself. If you look at the picture here, this is part of Orbi. And this is one of the curved walls that we actually built out of the very, very thick plasterboard that we use in the standard partition for cinemas. So we can build walls, as I said, up to 20 meters high. The gypsum partitions are very, very easy and quick to install. It's a very, very lightweight compared to block, as you all will know it. Sometimes we calculate it to be as much as 10 times lighter than block work. The typical gypsum Auditoria to Auditoria wall with the 3 layers of type X on either side will actually give you up to 3 hours fire resistance. And we are able to give you a wall now that can perform up to 78 decibels. So the first wall, which is basically the public area partition, this is just a double board on each side. And as you can see, the acoustic rating that we can achieve on this very, very simple wall is 66 dB. Typically, as we've noted there, the width is 300 millimeters. That is to achieve the acoustics. If you have walls over 9-10 meters high, this width must increase. So to all of the designers out there, the first thing that we will be asking you when you come to us is just exactly how high your wall will be. And then it's from that point that we can actually design the wall for you mechanically. So acoustics don't always take precedence when we're doing the design of a gypsum partition within your cinemas. If you can see here where I'm highlighting, this is our V-brace system. This allows us to connect the studs together without any significant loss of acoustics. So this is almost like, as I mentioned and showed you earlier, this is almost like an independent stud system. So this is how we achieve our high acoustic ratings on our walls. Putting the extra boards on there and making the wall wider, we then get our Auditoria standard partition, which achieves 71 or 72 decibels. Again, the minimum width for this to achieve the acoustics is 400 millimeters wide. But I must emphasize that we've got to look at the heights of these walls, because it's the heights of the walls that determine the minimum width of the partition. So these boards that you can see highlighted that we've got on here, these are the R-Type X 15.9 Type X boards, which are very, very high density, which help us achieve these high acoustic performances that you can see. And this is our R72 twin frame system. We also have walls going up to 74, where we're actually looking at a 4-board system. And what we've actually done here, we've introduced a new type of board, and this should be of interest. This board is basically known as a fiber rock board, and this allows you to screw the speaker systems direct to the wall without any use of noggins. So this is an option for you out there, so you don't have to put timber mattresses or noggins in to mount your speakers, as this board here has the strength in itself to take the fixings for the speaker systems. Plus, due to adding this board, we get a much higher performance. We're now looking at 74 decibel reduction or weighted sound reduction between the Auditoria to Auditoria. So these are some of the curved walls that we can do with that construction. So we can have this 6-layer twin frame and still achieve very, very tight radius walls for you to give you the feeling or the design that you require within your buildings or your cinema complexes. We also have our own track that goes at the bottom, which is a flexible track, which saves hours of people trying to snip the standard track that you would normally use on a partition. So these are all things that to help you move forward with the designs and giving you the look that you need for your cinema. And again, with the MAM, we provide the full system, so we will actually give you all our finishing solutions as well that are all produced in the region. So we're giving you the complete system. So the gypsum boards are manufactured in Oman, the metal is manufactured in Saudi Arabia, and the compounds are manufactured in Dammam and in Turkey. So everything is locally sourced for you and for your developments. The ceilings is a vital thing to want to stop the flanking noise or the sound from outside of the building, such as if we have a flight path over, which we've had quite a few times in cinemas. We don't want the sound coming through from the outside. Also, as I mentioned earlier, we have to reduce the noise from any plant that might be on the roof, and the ceiling will also help you stop sound flanking going over the top, which is the weak point of the system. This is this area here, which is the mass barrier, and then we have our absorbent ceiling options for you to give you the NRC within your auditoria, to give you the reduction or in reverberation that is required within a cinema. So as I've just mentioned earlier, some cinemas are recently they've been designed or built under the flight paths. So we've managed to reduce the noise so that you can't hear the planes coming in. The mass barrier ceiling solves this issue, and also, as highlighted on this slide, it helps to stop any flanking sound that's going over the top. So when we're actually looking at the mass barrier ceiling itself, so this is the mass barrier. These are the 3 layers of board on the mass barrier. What this is doing, it's meaning that any sound that's coming up through the ceiling cannot travel across the soffit line and come back out and come back into the auditoria. So we have our full-size partition in this area, which we were discussing with Paul last month. So this soffit then determines how we're going to design this area. So we have these cloaking pieces to help with the stop of flanking sound. We have these boards that can protect the sound of any plant that you may have in here, or any external sounds that are coming through in this direction. And then we have the absorbent ceiling below. So it's basically the mass barrier is consisting of 3 layers of sheetrock type 15.9 type X on a metal suspension system, and these are then supported on threaded rod systems. Often these threaded rod systems we continue through the mass barrier. So this area here, you see that threaded rod system would actually take that through the mass barrier for you, and then those threaded rods become the suspension system for a lot of your M&E that you wish to have in this area. And the second acoustical system below the mass barrier is suspended by wires from the mass barrier and into the furring is the easiest way for this to be actually done. So this is a typical section. So when we actually look on site, we do sometimes have this problem where we've got furrings and we have got a ceiling that isn't capable of taking the fixings of the partition direct to the head. So what we will build a bulkhead system or an umbrella system underneath. As you can see here, this is the framework that we built for this and designed for the contractor. And then the actual acoustical partition wall starts below what I call the umbrella head detail or this bulkhead detail. So this basically gives us the lightweight framing that we need here, and then the load of this whole wall is then transferred to here onto the bulkhead rather than onto the purlins, so we don't get the twist force onto the purlins, and then we can introduce our deflection in this area, and that reduces the load and also stops, because we've hidden here, we help reduce the flanking transmission that goes over from one side of the wall to the other. And then for the reflective ceilings, this is basically the absorbent ceilings, we have our halcyon, which has basically got an NRC rating of 1, and we have a CAC reading of 35. So this is ideal for the inside of the cinema, and we can basically either have it so that we are highlighting the grid, or we can actually have it so that the colour of the tile itself matches identically the grid colour, because we would use exactly the same paints in the same factory, so we don't have that variation in colour if that's what you require. Then we have the Lunar High Cac, which is an alternative system on here, where we have a wet felted mineral fibre substrate with a fiberglass over the top, and that can be finished. This is the Lunar High Cac, and as you notice, again, we get an extremely high NRC, but we get a very, very large CAC. And there's a lot of the acoustic engineers that now are very, very interested in this product, because it means that we may actually be able to reduce the mass barrier So the number of boards that we have in the mass barrier can be reduced because of the high CAC performance of the resilient or the absorption board system that we have above. And this is the grid, as you can see. So all this, the grid again, is manufactured in Dammam. It can be manufactured to any RAL colour that you actually need, dependent on the minimum orders. If you're having the black and you don't want it to be seen, we actually paint it with exactly the same paint as we do the Halcyon or the High Lunar CAC tile. So we would use exactly the same paint to conceal that. And then just moving on, for your lobby spaces, where USG Baffle has moved very much into some of the speciality ceilings. So what we've got now are out there as options in the market for you. We have this ensemble, which is like a gypsum ceiling, but is again very sound absorption, which has an NRC of up to 0.9. So you get a completely monolithic looking ceiling with a very high NRC rating. And that can be available in any colour that you wish, or any Pantone colour that you wish. So we can actually manufacture the spray that goes onto this board to any colour. So that means that you now have options of any colour within your cinema or your entrance foyers with a very high NRC if required in any colour that you wish. We also now produce the metal baffle ceilings, so we are very interested in your designs into the metal baffle ceilings, because whatever you want to see, we will try our hardest to work out a way of manufacturing for you so that your ceiling is different to the ceiling that was before. So we've produced these metal baffle systems. And metal canopies we can give you as well. And geometrics. So we've got a large option, and please feel free to contact us at any time to talk about our special ceilings that we can offer. And that's it. If there's any questions out there, I've just had a message too that I've been a little bit loud. I do apologise for that. There's probably some setting on my computer. Apologies for this. Thank you.
Thank you, John, for this presentation. I'll be accepting now the questions to the chat box. John, what would be the maximum height for the 20 framing system?
The maximum height that I've actually built up to now was in Qatar, and we went up to 22 meters. But when you do that, you need a very wide wall. So the wall that was in Qatar that we built was 575 mil thick, if I remember rightly.
This will achieve which acoustic performance?
Because of the default that we had there, because it had to be wide and had to have the 3 layers of board on there to give it its racking strength, we got a very high performance. And I believe on site, when we finally tested it, we actually achieved 72 on site. So in a laboratory, that could have well have achieved 78 or 79.
I have another question from Mr. Ryan Arbabi. Do you consider wall acoustic performance in terms of RW and STC, or do you consider lower than the RW STC ranges?
We look at both the STC and the RW. It's usually dependent on where the architect or the operator is based. When we're looking at operators from the Americas, they're always requesting things in the STC range. But when we talk to European architects, it's more often that they will ask for RW. There's little difference between the two in truth.
And another question, is there another outer protection materials or treatment other than plasterboard and wall? Do we have already CMU wall in the auditorium? So if they have CMU, can they use it for Auditoria, or they need to replace with the plasterboard, John?
Well, with the CMU wall, it does have a performance, but I would always recommend, to be honest with you, to move forward with a full gypsum partition. We have previously lined CMU walls to increase the acoustics for that wall. So quite often we will end up lining, especially on some of the refurbishment areas and malls. We've actually taken a CMU wall and added a wall lining to it on either side to achieve the acoustics that are required.
Another question we have, what should be the maximum panel dimension, length, width, and thickness required as per the auditorium to auditorium, calculated by area as per the rule of thumb?
They typically, the thicknesses of walls, as I was mentioning before, are all determined on the height of the wall, but more often than not, we find that from 15 meters down that you can achieve most of the acoustics and most of the fire performances with a wall of 450 wide from Auditoria to Auditoria, and of about 375 to 400 for Auditoria to circulation space. So there's a rule of thumb. It all depends on the height for the rule of thumb when you're doing this calculation.
We have another question from Mr. Ryan Arbabi. Do you only consider partition acoustic performance in terms of RW and STC, or do you consider lower frequencies?
No, the RW and the STC are basically it's the mean figure that you get, but when you get the laboratory reports back, and this is what we work very hard on, we have to look at the very, very low frequencies on the new cinema types, and that's one of the new developed walls. Possibly the last wall I showed you was specifically designed. The 78 dB wall was specifically designed to be achieving 45 at 125 hertz. So we were actually more interested in what was occurring at low frequencies and how to reduce that sound at low frequencies. When we designed that wall, we knew that the typical range, which is taken at 500, we knew that we were going to pass what the requirements were, but it was the 60 hertz and the 125 hertz that we had to really concentrate on to meet the performances that were being asked for because of the new speaker systems that have been developed. Sorry, I can't hear you as well.
Thank you, John. Before we continue on with the questions, I would like to share with the participant that we just launched this month our online chatbot channel, which is connected to the WhatsApp. So I would like just to share, this is the chat channel number. The good thing that you can have a full technical support 24/7, 365 around the clock. You can have an instant support from this channel. You can order a full sample management. You can track your samples. You can have a direct access for our products catalog. You can find the nearest sales office, the nearest distributor. You can register for the coming webinar as well. Even you can become a distributor. You can find the inspiration solution page, and we have extended to send complaints. So this is our chatbot number. You need to add the 966 if you can just register it for the WhatsApp 966-900-35672. And also this is the landing page where we have launched recently. This is one of the recent innovation, just to make sure that we are closer than before with our stakeholders, with our developer, designer, clients, and contractor, to make sure that we are always serving their request on time. We'll go back, John, to the questions and answer session. Please, just if you can send your questions. I think that we came to the end of this meeting, John.
Okay.
Again, sorry, yes, John.
I was going to say, this was originally planned as a single webinar for Paul and I, so we've managed to drag out cinemas now for two full hours, I think, or was it 2.5 hours? So I'm not surprised everyone's just about out of questions by now. Yeah.
Yes, indeed. And this is the continuation of the last session we did in your presence and our colleague, Mr. Paul. It was in May. The coming will be the on the 3rd of August. July will have no webinars, and the last Tuesday due to vacation season of Al-Hajj Eid. I would like to remind all participants that you'll be receiving attendance CPD certificate after this seminar. Also, you'll be receiving the recording link. Thank you all for being part of our monthly webinars. Really, this is something it's giving us a motivation. We'll keep in touch with all of you. Thank you, particularly John, and have a nice day for all. Thank you.
Thank you.
Thank you.